Hi, my name is Mohammed Tariq, and today we will implement the heap data structure. Let's first quickly recall three formulas that we learned in the complete binary tree lecture because these formulas are very important and we will use these formulas in implementation of the heap binary tree because we will implement, as we know, we implement the heap structure using arrays. So we must know how we can go towards the parent and how we can traverse towards the children. For parent, the formula is I divided by 2, right? So I is the index number. For left child, the formula is 2I, right? And for right child, the formula is 2I plus 1. Okay, so this is just for recapping the three formulas because we're gonna use this for these formulas. So now let's start the implementation, and I will start the implementation from scratch. So I have NetBeans IDE, and I will use this NetBeans IDE to implement the heap data structure. I will show you the code how we can implement that. And on my right hand side, I have the PowerPoint presentation where I will draw the tree structure and also the array, and I will show you how the changes the code is making and how what is the effect of the code and how we can create and we can insert data into the heap. So let's call this min heap, right? So the class that I'm creating is with the name min heap. So I have a fresh class. There's nothing in this class. So let's first implement the heap structure. Let's say private. Let's declare the integer array and let's call this heap. Okay, because we will implement the heap using array. And then let's initialize the second variable with the name size. And let me initialize the third variable with the name max size. So the logic behind the size and the max size is that we can have an array of, for example, we can have an array something like this. So I have an array of like this. So I have 0, 1, 2, 3, 4, 5, 6, 7. So this is the eight size array. The size of this array is 8, but it is possible that I would only insert three values, right? For example, 0, 3, 4. So the idea here is the size of this array is actually 3, but the max size is 8, right? The max size is 8. So here this is the distinction between the size and the max size, right? Okay. Now let's implement this the constructor. So in this constructor, I will want the user to give me the max size. So I will say int max size, right? So what I will do is this dot max size is equals to max size. So I'm assigning the max size given by the user to the class variable. The class variable, I mean the variable uh, I've declared here. It's actually an instance variable, but by class I mean I'm referring the current class. So the next is size. So the size is equals to 0, right? So as the user will insert the values, I will increase its size. The size is actually referring to the number of elements in the array, right? Now initialize heap. Heap is equals to new int array, and here this dot max size plus 1. Okay, I'm adding 1 here. Okay, so I think this is it. And now let's implement the, okay, before going to the insert method, so what I want to implement these three methods, right? So here, for parent, for left child, and for right child, right? So what I can do is I can say private integer, and I can say parent. So what I will do, I'm taking the position, index position, right? As an input parameter, the user will give me the index position, and then this method will return the index position of the parent, right? Of the parent of the index position. Okay. So for example, let's say I have an array here, and let's say I have this sample array, and I have some values, let's say 3, 2, 6, 8, 9, and this is 0, 1, 2, 3, 4, 5. So I want to know the parent of 8. So what I can say, 4 divided by 2 is equals to 2. The parent of 8 is 2. So when I will give 4, the method will give me index number 2, right? So it will return it will return index position divided by 2, right? It's easy. It's really easy. So in the same way, I can implement int, and I can say left child, and here integer index position, and this method will give me return 2 multiplied by index position. Okay. So for third method, I have integer right child, integer index position, right? And this method will return me 2 multiplied by index position plus 1, right? Index position plus 1. I have implemented these three methods, and these methods will help me in traversing within the array. Now, for insert method, I can write the insert method in front of you, but my strategy and my approach is to copy the code I have written in the insert method. I will copy the code here, and then we will debug the code, and then I will show you line by line how this code actually is working. I will draw the array and tree for you in the PowerPoint presentation. Then we will see what implementation is actually doing. So here I have insert method and I have swap method, right? So actually what swap is doing, swap is swapping two values. It's very simple method. There is nothing complicated. It's actually swapping two values with the help of a temp variable. And insert method is actually inserting values in the heap, right? So now let's implement the main method and also implement some values, also insert some values. So we will say public static void main, and let's initialize the min heap. Heap equals to new min heap, array of size 10. Now let's start inserting some values. I will say heap dot insert, and let's say first element I'm going to insert is 20. Okay. Then heap set dot insert, next value I'll insert 25. Heap dot insert, then I will insert 30. Heap, okay, let's insert some lesser value here, 15. Heap dot insert 50. Heap dot insert 12. Heap dot insert 20, 28, or let's say Okay, so let's insert these values and let's say what effect this will have on the heap and how the heap will be created. So let me run this in debug mode, and with the code I will show you line by line how the insert method is working and what effect it will have on the actual heap structure. Right, start in the debug mode. So now we are standing here at line number 64, and let's draw a tree here, sorry, an array here. Okay, let's draw an array, a sample array. Okay, so and let's draw some. So this is the array. We have index 0, 1, 2, 3, 4, 5, 6, 7, and 8. I think uh, I have 10. The size is 10, but here I have the size of 9. But this doesn't matter because we only have how many values? 1, 2, 3, 4, 5, 6. We only have 6 values. So let's insert the first value. So now we are calling the insert method, and now we are and on the first line of insert method. So size plus plus. So actually the size is 0. Okay, you remember we started with the size of 0. We initialize the size as 0, right? Here we have 0. So we are adding 1 to the size. So the element is on will be index 1 because we have added 1 to the size. And now, so the first value we have is 20. So 20, okay, we have 20 here. And we also have a tree with the element 20. Okay, we have first node with the node with the data 20. Now we have current equals to size. So current is, you can say, it's a kind of a pointer. It's a pointer which is pointing on the size. So let's say the current. So the current is here. So this is current. Current is now actually pointing towards first element. Okay. Now here we are checking heap of current, right? So the current is actually 1. So data of 1, heap is an array, and current we are giving as an index number. And here you can see what we are doing, parent of current, right? As you can see what we are saying, parent of current, right? Parent of current. So this means this method will give us the index number of parent. But here, because we only have one element, so there is no, so the parent of will be 0, and on 0 we have nothing, right? Okay, so it has came out of this while loop. Now the next element is 25. Let's insert 25. Let's insert 25. Here we have 25. Okay, it will be inserted on the index number 2 on this because the size we have added 1 to the size. Now the size is 2. Okay, now the current is pointing towards, so the current is now pointing towards next element. So now the current is pointing here. Okay, and now let's check. uh, so we have one more thing which is this 25. 25 is added in the tree as a child of 20. So now we will check that if the current is less than its parent, right? This while loop, the condition is current less than its parent. So 25 is not less than 20. So this while loop will not run. So as you saw, this condition is false and the pointer came out. Now the third element is 15. Let's insert 15. So let's insert 15 here and also insert 15 here. Okay, now we have 15. So current is equals to size. So now the size is 3. So the current will also point towards the index number 3. Okay, so now the current is pointing towards 3. Now let's check, is current, so this is current, right? The current is 15. Current is less than 20. Yes, current is less than 20. So now it will come inside this while loop. So here we are calling swap. Okay, and the swap, as I told you, is just swapping two values. So it will swap 15 with 20, right? So now let's swap the values. Let's swap the values. So we will have 15 here and 20 here. Okay. So now same thing will be here. 15 will come here and 20 will come here at index number 3. Okay. And now what we are doing, you see, current is equals to parent of current. So now what I am doing is now the current will be pointing towards the parent, right? So the parent of current is 15. So now here the parent of current is at 20 and the parent is 15. So now current will point towards 15. Okay. Now it will, because it's while loop, so it will keep on checking the values until this condition becomes false. Now the current is 1 because the current is 1. Now it will check the parent of 1. Okay. Now because the 1 does not have any parent, so it will come out. Now next is 50. Next is 50. So let's insert 50. Let's insert 50 here. Okay, and insert 50 here because we are moving from left to right. You remember we discussed this, that when we will insert in the tree, we will move from left to right. So now current is equal to size. Now current will go to 50, right? Current will go to 50 and we will remove this current from here. Okay. Now it's checking that if current is less than its parent. So the parent of current is 25 as we can see in the tree, and the current is not less than 25, so this loop will not run, right? Now the next is 12. Let's add 12. So here we have 12. Let's add this 12 in the tree also. Let's Okay, right? Now the current will move to the size, so it will move. So we'll move the current pointer. We will move the current pointer to the newly added element, and we will remove this from here. Now let's check if the current value is less than its parent, and yes, it is. The value of current is less than its parent. Okay. So what we will do? It will come in the while loop, and we will swap the values. So we will swap 25 with 12. So here let's swap the values. Let's swap the values and we will write 12 here and we will write 25 here. So in the same way, we will swap this from index number 2. Okay. So I will write 12 here and I will write 25 here. Okay. Now the next line says current is equals to parent of current. Now what is the parent of current? So the parent of current is, so now the current is 25, so the current is standing here. Where? Here. The current is standing here and the parent is 12. So now this current will move towards 12. So now the C will move towards 12. Okay, and then we will remove this from here, right? And now this loop will again check if the current, now the current, you see, now the current is at 12. If the current is less than its parent, the parent of 12 is 15, and yes, 12 is also less than 15. So it will come in this while loop again, as you saw, and now it will swap, right? The code will swap the values. Now 15 will be swapped with 12. So now here we will write 15, here we will write 12, and now it is 15. So in the same way, the effect will be there it's actually the array which is changing, but I'm showing you in the tree because it's easy to understand for you, right? So now here I have 12 and I have 15 now. Okay. Now the next line says current is equals to parent of current. And now the parent of current is 12. So let's move the current pointer to its parent. So let's move the current pointer to its parent, which is 12. And same goes with here, and remove them from their previous locations. Now the while loop will give us false result because we do not have any parent of 12. So it has came out. Now let's insert 5, and 5 will be inserted here. Okay. So 5 will be inserted. 5 will be inserted here. Okay. As a left of 20. So here it is 5. So now the current will move to the newly added element. So we will move current here. Okay. So current is actually on 5, and we will remove this from their previous locations. And now let's see. Now let's see. Current is less than its parent. Yes, it is less than its parent. 5 is less than 20. So what we will do, it will come inside this loop and we will swap. So let's swap. Okay. So let's swap 20 with 5. So 5 will come here and 20 will come here. Okay. So in the same way, we will swap. So actual just these changes will actually be done in the arrays. Okay. So 5 will come here and 20 will come here. Now we will move current. Now current will point to the parent of current, and the parent of current is this 5. Parent of current is this 5, and we will remove these from here. So now this while loop will again run, and it will check that the parent of current. Now the current is less than its parent. Yes, in this case 5 is less than 12. So what we will do, it will come inside the while loop. The pointer will come inside the while loop, and we will swap the values. So let's swap. 5 will be swapped by 12 will be swapped by 5. So 5 will come here and 12 will come here. The same way, let's make changes in the array. 5 5 will come here and 12 will come here. And now we make the current to the parent. Then now the current pointer will point to the parent of current. The parent of current is 5. So here, and it will be removed from here. Now it's completed. So now we have inserted all the values, and you saw that how this insertion happened and how we created a heap structure. Now it's a heap structure, and the effect of this heap and how we swap the values. I showed you using the array. Okay, I showed you using this array, and also I created the tree, and we saw the effect of every insert on the tree. So I hope this will be helpful for you, and this code is not very complicated, but for those who have any issues, they I would recommend you to debug yourself and try to understand this, and you will get this very easily. Thank you for watching.